This should do it. All right. Let's do that first one. Let's do the first problem. First things first, in doing PEMDAS, your job is to get everything inside the parentheses. So I'm going to draw over this little character guy, 8 divided by 2. Inside the parentheses, I have 2 plus 2, which is 4. Now what I do is I go left to right. Remember, PEMDAS is not always do multiply before you divide. It's always multiply, divide, left to right. So the first thing I'm actually supposed to do is supposed to do 4, then times 4, and I'll get 16. That's right, boys and girls. This is that crazy problem that you see on social media where people are like, everybody thinks it's 1. And everybody does think it's 1 because at this part, they're like, oh, well, 2 times 4 is 8 and 8 divided by 8 is 1. Wrong, 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 wrong. Wrong, 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 wrong. Let's do this one. Negative 4 minus, inside parentheses. 1 minus 5 is negative 4 minus, parentheses and an exponent. Let's kill 2 birds with 1 stone. Negative 4 in parentheses squared is going to be positive 16. You with me? You can't answer. Negative 4 minus a double negative 4 is going to be negative 4 plus 4 minus 16. 16. These guys cancel each other out, and I'm left with negative 16, baby. 16, negative 16. Look at that. Our objective for the day is I will be able to solve equations, evaluate expressions, and calculate probability. Do I think we can do this quickly enough? Probability. Okay. Equations, expressions, and probability. You learned back in the day, way back in the day in the Stone Age, about solving equations. That was like early last year. And then they brought forth this wonderful thing called distributed property. Well, what I'm going to do, and this is how I'm going to handle our notes. I'm going to kind of, when I have these lessons, I'm going to go through them quickly. And then tomorrow, you'll see an assignment that'll kind of help you understand everything that's going on here. And then tomorrow afternoon, I'll actually, we'll go over these types of problems together so that you feel comfortable. So if it feels like I'm going fast today, I am, because I'm just kind of reminding everybody how to do these problems. So, just try to watch, try to keep up, and I think you guys will be fine. I wanted to show you this video on how to solve a regular two-step equation. So what I'll do instead is I'll find that video on the YouTube, and I'll paste that into your Google tab so you can quick watch it, just to make sure that you feel comfortable. You probably already saw this before, all of those who are super followers. Let me share, copy, and I'm going to quick paste this into your screen. Actually, no, let me we'll show it this way. Boom. We'll show it this way. I forgot that I can do that.
All right, solve for y. We have to get y all by itself. Negative 2 and positive 8 are in the way. In order to get rid of those two things, we have to do the opposite. Always get rid of the number floating around first, and that's positive 8. The way we do that is we subtract 8 from both sides, cross that out. That leaves us with negative 2 on the left equals negative 5 minus 8 is negative 13. Okay, y is still not all by itself yet. You have to do the opposite of what negative 2 is doing to y. Since negative 2 is being multiplied to y, we divide both.
Why? Divide both sides by negative 2, and after you divide both sides by negative 2, you'll get negative 13 divided by negative 2, and the answer is 13 over 2. Good job, everybody. Let's go back to our screen here and get rid of that YouTube that just decided it would not work. All right, so that kind of crapped out on us. No big deal. Let's do these problems. We have 2 times a distributed property problem, 2 times parentheses, n plus 5. So what we do, according to that little picture down there, is we're going to distribute 2 to both of them. 2 times n is 2n. 2 times 5 is 10. You with me? Equals -2. Now it's just a regular old-fashioned two-step equation like the video tried to show you before it went kaputski. Subtract 10 from both sides. Cross it out. Bring down the 2n equals -12 minus 10 is -12. You see what I did there? I accidentally said -12 minus 10 when I should have said -2 minus 10. Look at me thinking ahead. Is n all by itself? No. What's in the way? 2. How do I get 2 all by itself? Or n all by itself, divide 2, divide 2. N equals -6. Okay. Okay, good. You're all still watching me. Yay. All right. Next problem. Is m all by itself? No. What's in the way? 9 is in the way because it's being divided, and -1 is in the way because it's floating around. How do I get rid of the -1? Do the opposite of -1, which is +1. +1 from both sides, cross you out. Always get rid of the thing that's floating around first. Okay, always get rid of the thing that's floating around first. I have -2 plus 1 on the right, which is -1. Now take a look at what I have. Is m all by itself? No. What's in the way? Divided by 9. How do I get rid of divided by 9? Multiply both sides by 9, of course. Multiply both sides by 9. M equals -1 times 9, which is -9. Boom! And of course, if I wanted to, I could take that guy right there and plug it in to m. So I could be like, let me see, m is -9. So -9 divided by +9 is -1. And -1 minus 1 is -2. Hooray! Hooray! Oh no! Look at that. I have an A on the left and a -5A on the right. I don't know what former teachers told you, but this current teacher is telling you that if you see an A on the left and an A on the right side of an equal sign, I prefer to get rid of the smaller one. If you have a variable on the left and a variable on the right, you have to eliminate one of those variables, and I prefer to get rid of the one that's smaller. -5A is smaller. How do I get rid of a -5A that's floating around? Add 5A. Add 5A. Cross you out. Now I have A plus 5A becomes 6A. Drop down the +5, drop down the equal sign, drop down the +5. One of you might be thinking, sir, why didn't we get rid of the 5s instead? I prefer dealing with the variables first because sometimes the variables disappear and magical things happen. Now, what's weird with this problem is the variable doesn't disappear. However, if I'm getting A all by itself, when I subtract 5 from both sides, that happens, and logically, that's going to happen. So 6A equals 0. Oh no, I must have done it wrong, you think, because I got a 0, and surely you can't have zeros. First off, don't call me Shirley. And second, yeah, you can have a 0. I can divide both sides by 6 and get 0. And that's what I'm going to get. A equals 0. That's my answer. Sometimes 0 is the answer to the questions. I could be like, hey, what's that in your wallet? And you would be like 0, and ha, I got you. Oh, boy. More distributed property problem 4. This little process right here is called distribute a negative. See the negative living on the outside of the parentheses, and inside the parentheses, I'm doing stuff? Take that negative and multiply it by everything on the inside. So negative times x is -x. Negative times +4 is -4. Distribute the negative. Distribute the negative. Distribute the negative. Is x all by itself? No. What's in the way? That negative. Anything else? That -4. What should I get rid of first? That -4. How? +4. +4. The negative x on the right drops down. -8 plus 4 is -4. Is x all by itself? No. What's in the way? Negative. So how do I get rid of a negative in front of x? Well, the negative in front of x is the same exact thing as -1x. x. So I'm going to divide both sides by -1, divide both sides by -1, and 4 equals x. However, I hate the way that looks. You guys learned about, oh gosh, what are they called? Inequalities last year, where you had to do like greater than and less than, and you had to draw things out and point things in a specific direction. Now, it really only works if x is on the left. So what I'm going to do, I'm going to just flip it real good. X equals 4 instead of 4 equals x. X equals 4. Cool, man. Cool, bro. I still have everybody. I think I have everybody. That's good news. I have all of you. Oh my gosh. Oh my gosh. Looks like I want to play that video. Let's try a video again while you take a look at these problems. These videos have to do with solving variables with wacky distributed property and all this crazy stuff. So let me find the video for you to watch. I didn't think the videos would not work. That's why I'm doing this now.
All right, distributed property everywhere. We have -3 multiplied to a parentheses. We also have just a regular old negative multiplied to a parentheses. So let's get to it. -3 times positive 2x is -6x. -3 times -5 is positive 15. Negative times 6 is -6. Negative times positive 5x is -5x. Now what we have to do is we have to get rid of one of these x's, because there's an x on the left and an x on the right. I'm going to add the 6x from the left, because I know by adding a 6x to a -5x right here, I'm going to get just an x. Minus 6 drops down, that's a positive x. 15 drops down. In order to get x all by itself, I add 6, I add 6, 21 equals x, or x equals 21.
Ooh, 9 plus 10. Remember that? Oh, boy. Oh, that poor kid. I wonder how he's doing. All right, so you saw what the handsome guy on the video said. You have distributed properties, so let's do it. Let's do it to it. -4 times 1 is -4. -4 times -6a is positive 24a. And on the left, I have positive 24a minus 22. So this is the part where in the previous problem, I was like, if you have a variable on both sides of the equal sign, get rid of the smallest one. Well, they're the same. So let's just get rid of just subtract 24a minus 24a. Cross that out. Cross that out. -22 equals -4. Where's my variable? I don't have a variable. Does -22 equal -4? No. So what's my solution? There is no solution. When your variables disappear, friends, and you're left with something that just simply doesn't make sense, the answer is no solution. Let's see if that happens here. Distributed property, 2 times 4x, 8x. 2 times -3, -6. Minus 8, 4, 2x. Oh, look what I can do right away. I can combine like terms. Ooh. -6 minus 8 is -14. So I have 8x equals 4 plus 2x. It looks like nothing special happens here. It seemed like when I had the 24a over here and the 24a over on the other side, they just cancel out. Well, they do. That's a shortcut. I don't have that going on the right side equation here. So I'm just going to subtract 2x because it's the smaller of the two, minus 2x, cross u out. 6x minus 14 equals 4. Is x all by itself? No. What is in the way? Negative 14. 6 is also in the way, so let's add 14 to both sides. Add 14, and that gives me 6x equals 18. Divide by 6. Divide by 6. Let's put it over here. X equals 3. Cool dog. Cool dog. Cool bro. Cool dog. Cool son. Evaluate. Oh man, that was me in high school. Fun fact. It was. How many of these do we have? Ugh, all right, we'll do them quick. No big deal. When your job is to evaluate, it gives you, this is called a number sentence, and then it tells you to plug stuff in and then do a little bit of math like PEMDAS. So I have z, which is actually 6. So I'm going to replace z with 6, parentheses 6, divided by 6, plus x, which is 1, plus x, which is 1, minus 5. According to PEMDAS, I have division, I have add, I have subtract. According to PEMDAS, I do division first. So 6 divided by 6 is 1, plus a 1 that doesn't need the parentheses, plus another 1 that doesn't need the parentheses, minus 5. Now I can just work left to right. And I'm just going to do it all in one swoop. 1 plus 1 is 2, plus 1 is 3, minus 5 is negative 2. Baby. 8. I have 6 plus q. Well, q is 1, so 6 plus q. Hey, q, Russell, that's your brother's name. Plus 5 minus q, which is 1. Hey, Russ, that's your brother's name. Minus p, which is 1. All right. Inside the innermost parentheses first, I have 1 minus 1, which becomes 0. So you're useless to me. Now I have this guy, which is just a simple math problem. 6 plus 1 is 7. Plus 5 is 12. Oh my gosh, I didn't even notice that. Oh, that's right. If I add the plus 15 at the end, nothing changes. Plus 15, plus 15, 27. Hey, good job, guys. Good job, everybody. I feel very unconfident that I did that right, but I did it right. I did it right. I don't think unconfident's a word. Remember probability? Hey, man, roll these die. Roll this number cube and spin that spinner. Probability is the favorable outcomes, what you want out of the total outcomes. Okay, when I look at this, I have 4 different colors that are they're equally distributable, if that's even a word. If I spin this spinner, I'm just as likely to get a purple as I am to get a green, as I am to get an orange, as I am to get a red. Or for those of you who are colorblind, I'm as equally able to get a gray as I am to get a gray, as I am to get a gray, as I am to get a gray. So what's the probability of me getting an orange? Well, there's 4 possibilities, so the total outcome is 4. Only one of them is orange, so 1 out of 4. That's it. What's the probability of me getting a red or a green? Well, there's 4 possibilities here, so my total outcomes are 4. One of them's red, and one of them's green. So that's 2 possibilities, 2/4. And then one of you's like, oh, sir, can't you simplify that? Yes, I can simplify that. Not red. You're not red. You're not red. You're not red. So since you're not red, that's 3 options out of 4 possibilities. All right, how many of these are pink? None of them are pink. So the possibility of getting a pink is a 0. A big fat 0. Simple probability. Ooh, look at all these marbles, 12 in total. What's the possibility of me getting a red? There's 5 of them, and there's 12 total possibilities, so 5 out of 12. What's the possibility of me getting black or blue? I'll tell you something. You get me upset, there's a 100% chance of you getting black and blue. Get it? Bruising. That's 6 of them. 6 of these are black or blue out of 12, which simplifies to half. No, 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 no. What's the possibility of me getting non-green? Well, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I didn't mean that one. 11 of them are not green out of 12 possibilities. Easy peasy. What's the possibility of me getting a rabid squirrel? None of these are rabid squirrels, so 0 is the possibility of me getting a rabid squirrel. Mr. Abbott, remember him? He hated squirrels. Do I have enough time to do this one? Yep, perfect. All right, so I have a deck of cards, which is 52 cards. Okay, now just a quick look at it. Half of these are black, half of these are red. What's the probability of me getting a red? Half. This is out of 52. What's the probability of me getting an even number? Well, you 4 are an even number. 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 And you 4 are an even number. That's 5 groups of 4. 5 groups of 4. So 5 groups of 4 is 20. 20 out of 52. That was supposed to say 20, but there's a bit of a lag. Both of those numbers are divisible by 4. So if I divide the top by 4 and the bottom by 4, I get that. So the probability of me reaching into a random deck of cards and getting an even number is 5/13. A jack, queen, or king. So 4, 8, 12. 12 out of 52. Those are both divisible by 4 again. So divide the top and the bottom by 4, you get 3 out of 13. A black odd number. Ugh. All right. So I'm just actually going to count these out. A black odd number. So 1, 2. Oh, odd. Oops. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of 52, which is going to be 2 out of 13 after you simplify it. And then I have an even club or an ace. So even club is, I guess that's the club. Even club. 1, 2, 3, 4, 5. Or an ace, 6, 7, 8, 9 is 9 out of 52. Can't divide it at all. That's that. So that's the end of the lesson. We're not worrying about homework because, of this wacky world that we live in. So even though it says Google Forms, don't worry about it. Usually when we're in person, we're going to end the day with a grand finale. And the grand finale is a Pemdas problem, just like we saw in our warm-up. And a lot of people do it this way. A lot of people say 3 times 3, which is 9. But we now know that that is incorrect. See, what you're supposed to do is you're supposed to, do the parentheses first. And I have 6 divided by 2. But once you get to that stage, you're supposed to work left to right. So 6 divided by 2 is 3. And I actually did do it right. Look at that. I'm so smart that I didn't realize when I was trying to do it wrong that I did it right.